This is lesson 3 of the quantum mechanics mini lecture series. I'm going to talk about electromagnetic radiation, so EMR for short. So what is electromagnetic radiation? It's another word for light. Okay, anything which travels at 300,000 k's per second is an electromagnetic wave. How's it formed? How's an electromagnetic wave formed? Suppose you've got a positive charge, okay, or a negative charge, let's say, moving along in space. They create, or even just stationary, just sitting there, they create what's called an electric field. Okay, by definition, an electric field is something which, so an electric field is basically something which is given off by charged particles, and they affect other charged particles nearby, okay? So for a positive charge, they come out. For a negative charge, they come in. And if you have another positive charge nearby, the first positive charge, they will repel, okay? Because positives and positives repel, so like charges repel. But if you have a negative charge next to the positive charge, they'll attract, right? So it's like an invisible force field which extends outwards from a charge, okay? And I should write, so in physics, electric field is written as a capital E, E for electric field, and an arrow on top, sometimes there's a half arrow typically. That means that the electric field is a vector. Okay, anything with an arrow on top in maths or in physics is defined to be a vector. A vector is something that has size and direction. Okay, so electric field has a size, certain number, and it's got direction. It's got it points a certain position in space. Now on to magnetic field. So when a charged particle, let's take a positive charge, is moving in space, or when it changes speed, it creates what's called a magnetic field around it. Okay, magnetic field is given the symbol B with an arrow on top, or half an arrow. Okay, it's also a vector. And when electric and magnetic fields interact. Okay, this occurs when an electric charge, so let's say a positive charge, moves back and forth or accelerates. You get a changing electric field, and a changing electric field creates a changing magnetic field, which causes a changing electric field ad infinitum, okay, forever. Okay, so the electric and magnetic fields, they keep feeding off each other and they create a chain reaction. This is called an electromagnetic wave, an EM wave. This here. So a moving charge creates a changing electric field, which causes a changing magnetic field, which causes a changing electric field, etc., etc. And you can actually sketch this on a diagram. So here's a y and x axis. So in school, you're probably looking at just 2 dimensions if you're doing basic maths. You can also add a 3rd dimension, the z axis, we call it, coming out of the page. Let's imagine it's coming out of the page. The electric field, let's take the electric field to be going up and down, the y axis. Okay. Arrows indicate the direction of movement, so the electric field's changing. It's moving up and down, E. Let's suppose the magnetic field is coming out of the z-axis, back and forth, wiggling back and forth, back and forth. Oops. Let's call that B. And the speed at which this happens is the speed of light, 300,000 k's per second, as we saw here. So that's light. It's an electromagnetic wave. It's got changing electric and magnetic fields, and the electric and magnetic fields, it's important to note, they're perpendicular to each other. They're at 90 degrees in order for this to occur. And there's different types of electromagnetic wave. They're all the same thing, but they pretty much they vary in terms of their energy. So let me draw here. This is called the electromagnetic spectrum. Okay, you got radio waves, microwaves, infrared, visible, UVs, which is ultraviolet, X-rays, gamma rays. Okay, as you go across to the right, you've got increasing energy, okay, or decreasing wavelength in this case. Okay, X-rays are more deadly, more harmful than, let's say, infrared rays because they've got, okay, so these are all the sets of different electromagnetic waves. The most familiar to us is visible light. That's an electromagnetic wave, okay? The light that comes from light bulbs, TVs, that's an electromagnetic wave, okay? And if you were, in principle, able to change the wavelength of that wave, you can get different forms of electromagnetic radiation.